Okay, so now that we've talked about a paired samples t-test, we need to talk about an independent samples t-test. So the process is basically the same. If you remember, we're looking in this case at the mean sub 1, x bar sub 1 minus x bar sub 2. Now obviously that says mu sub 1 and mu sub 2 because it's the general what you can do, but since we don't have the mu's, we use x bars as estimates. And so we need the mean for one group, the mean for the other group, and then we need a standard deviation. Now this standard deviation is going to be the pooled standard deviation. Remember when we did that pooling stuff last time? Yeah, this is the pooled standard deviation. Then we're going to calculate delta, and delta is going to be a little different too. It's going to be the effect size times the square root of n divided by 2 in this case. Then we'll use the table to get what we need. So let's go ahead and do an example. Now, in this particular case, remember, we only get to use this one when we have equal n's. So this part right here, the delta, is going to be different depending on how many people are in each of the two groups. If they're equal, then we can do the effect size times the square root of n divided by 2. If they're not equal, then we have to do something different. That'll be the next slide. It'll be this part right here, and we'll get to that next time. So first of all, let's do the equal n's first. We're still going to pool that variance. We'll talk about it in just a second, but this is going to be different between the two independent variables. So let's do an example. So you remember we did this at one point, right? We did psychology versus business as to how happy they are, right? We had this information right here. Now what we're going to do is we need to get, this is the normal t that we used, but this right here is the pooled variance. We normally only use that when we've got two different n's, but in this case we need to make sure that we have the pooled variance as our substitute for the standard deviation for the population. So we're going to use this as an estimate of the variance of the population, and then we're going to square root it to get an estimate of the standard deviation of the population. We're going to make s sub p instead of s squared sub p. That's what we're going to be doing. So it's pretty easy up till then. In fact, you're going to see that this is going to get pretty easy pretty fast, but we need to get a mu sub 1 minus mu sub 2. Now, since we don't have mu, we have to use the estimates that we have, which is x bar sub 1 and x bar sub 2. So we need 6 minus 5. So here we go. This is going to be x bar sub 1 minus x bar sub 2 is 6 minus 5, which is 1. All right. 6 minus 5, which is going to be 1. That's not going to help anybody. So this is x bar 1, x minus x bar 2. Now the reason why we're doing this, just to remind you of what we're looking for, is, let me show you on this screen over here. We're looking at this top part. Instead of mu sub 1 minus mu sub 2, we have to use x bar sub 1 minus x bar sub 2. And then we're going to do that over the standard deviation. Now the standard deviation, though, has to be the standard deviation for the sample. And so we're not going to just use the normal standard deviation over here. We're going to use the pooled variance and take the square root of that. That's what we're going to use for our estimate of the standard deviation. So what we're going to do is we're going to go through this pooled variance and figure it out. It's going to be pretty easy because you'll see in just a second what's happening. All right, psychology majors, there's 2 of them. So that means the n is 2. 2 minus 1 is 1 times s squared sub 1. S squared sub 1, that's the variance of sub 1. That's the variance of psychology majors right there. That's 8. So 2 minus 1 times 8 is 2 minus 1 is 1 times 8. That's 8. Okay? Plus, over here, business majors, we have 2 of those. 2 minus 1, that's 1, times the variance, which is 2. So 8 plus 2 is what we're doing up here. 8 plus 2 is 10 divided by the standard deviation. Standard deviation is, there's 2 in this group, 2 in that group, minus 2 is 2. So we need 10 divided by 2. So we need 10 divided by 2 to get the pooled variance. Is 5. 10 divided by 2 is 5. Okay? Just to remind you, this is 2 minus 1, which is 1, times 8, the variance of psychology majors, plus 2 minus 1, the number of business majors minus 1, which is 1, times the variance of business majors, which is 2. So 8 plus 2 is 10 divided by 2 plus 2 minus 2, which is 2. That equals 5. The pooled variance is 5. Now this is variance, and we want the pooled standard deviation. That means we've got to get, well, we'll call it S sub p, because that's what it is. Look right here, this is S squared sub p. We want S sub p, so we got to take the standard deviation. We have to take the square root to get the standard deviation equals of this right here. Square root of 5 is 2.23607. Hey, look over here. Did we already do this once? Yeah, because it's going to be kind of the same. In fact, the whole estimate of the effect size when n is equal is going to be the same as t for this particular case. That's what it's going to be. Look when we find this. So d is going to be mu sub 1 minus mu sub 2, but we don't have mu, so we have to use x bars, divided by the standard deviation of the pooled variance. So right there, 0.447. So that is 0.447. This is our D for that particular case. Now, because we're doing independent samples t-test, we also have to do something different for the delta. And that means we've got to do delta equals D times the square root of n over 2. So that's total n divided by 2. We need the square root of that. So let's get n divided by 2. Guess what? The total n, there's 4 people in this whole study, right? 2 psychology majors, 2 business majors, 2 plus 2 is 4. We need to divide that by 2, and that's 2. So the square root of n divided by 2 is going to be 4 divided by 2, which is 2, and then we're going to square root that. So equals the square root of 2, 1.4142. Then our delta is going to be D times the square root of n divided by 2 times that, 0.63. So our delta is 0.63. Let's go ahead and look this up on the chart. So we just calculated delta as 0.63. When we look at the table, the biggest delta we've got right there is 1. So we know that in this particular case, the power is less than 0.17. It's not very good power. That's pretty bad. So what that means is that if there is a difference between happiness and psychology majors and business majors, if there is a difference, if I'm only using the 4 people that I'm using and there's an equal number in both groups, then I only have a 17% chance of finding that if there is a difference. Now in this case, we know we were going to reject it anyway, but that's a separate issue. So what I want you to do is I want you to work on this same concept with some old data that we had used before. So let's go ahead and use this right here. I want you to calculate the pooled standard deviation. So you got to get the pooled variance and do the square root of that. Then calculate your effect size, your delta, and then tell me what power is going to be. Okay, so to do this, remember, we need to first create our pooled variance and take the square root of that so we get the pooled standard deviation. So in this particular case, we have 1, 2, 3, 4 millennials and 1, 2, 3, 4 baby boomers. These are the means, 5 and 11.5. We need to get the pooled variance. So to get the pooled variance, we have to take n minus 1 times the standard ton of variance for each one. Okay? So in this case, n is going to be 4. I'm sorry, n is 5, minus 1 is 4. So 4 times the variance, and then we're going to do 4 times the variance over here. So 4 for millennials we're going to do 4 times the variance, and then for boomers, we need 4 times the variance of boomers, which is over here. Oh, it's there, right there. Oh, I didn't put equals, no wonder. Equals 4 times the variance right there. All right. We add those together. It's going to be 118.667. Then we divide that by the degrees of freedom, which is n sub 1 plus n sub 2 minus 2. N sub 1 is okay, so now we're going to do this for the millennials. Now the first thing we need to do is get the pooled variance so that we can get the pooled standard deviation. So we take the pooled variance and take the square root of that. So to get the pooled variance, first thing we need to do is take n sub 1 minus 1 times the variance. So there are 1, 2, 3, 4 millennials. So n sub 1 is 4. There are 1, 2, 3, 4 baby boomers. So n sub 2 is also 4. 4 minus 1 is 3, so we need to do 3 times the variance. So 3 times 4.667 plus 3 times 25. Add those up and divide by the degrees of freedom. So here's where we go. So let's do this for the millennials. Millennials, we get 3 equals 3 times the variance, right? And then for boomers, we get 3 times the variance, which is right, whoop, there, 75. We get the sum of that, and that's going to be 89. And we divide 89 by the degrees of freedom, which is n sub 1 plus n sub 2 minus 2. So n sub 1 is 4, n sub 2 is 4 minus 2. So 4 plus 4 is 8, minus 2 is 6. So the pooled variance is going to be this divided by 4 plus 4 minus 2, which is 6. 14.833. The pooled standard deviation, which is S sub P, is going to be the square root of that. Right there, 3.85. Okay, now that we have this, we can figure out D. So D is going to be mu sub 1 minus mu sub 2 over sigma. Now, since we don't have mu, we're going to use x bar. X bar sub 1 minus x bar sub 2. So 5 minus 11.5. And since we don't have sigma, we're going to use our pooled standard deviation instead. So d bar is going to be 5 minus 11.5 all divided by 3.85. Negative 1.688. That is our d bar. Then we can get our delta. We take the d, it's not d bar, it's d, it's the effect size, estimated effect size. We take our effect size times the square root of n divided by 2. The total n is 8. There's 4 millennials, 4 boomers, total is 8. So we're going to take 8 divided by 2, and that's going to be 4. So we need the square root of 4. Guess what the square root of 4 is going to be? Woohoo! Figured it out. Then we take, I'm sorry, we got to take this times the square root of 4. So we got to take d times the square root of 4. We need this times the square root of 4. No wonder. All right. And that will be negative 3.37. Now, for these, remember, we don't care about the negative versus the positive on the actual chart. So let's look this up. 3.37. Oh, that's pretty big. 3.37. That's pretty close to 3.4. But normally, what we do is we go down to 3.30. So our power is going to be 0.91. 0.91. That means that my hypothesis that baby boomers have more CDs, baby boomers have more CDs than millennials, right? If that's really true, then this test, based off of what we put in there, has a 91% chance of rejecting the null when that's true. Okay, now that we've done this for independent sample t-tests with n's of equal sizes, we now need to do it independent samples t-test for n's of different sizes. And to do that, we got to get this thing right over here, which is called the harmonic mean. That's what it's called. I'd forgotten for a second what it's called, the harmonic mean. So we're going to get the harmonic mean for this one. So we're going to do the same process what we just barely did. We're going to take x bar minus 1 minus x bar minus 2 over the pooled standard deviation. And then we're going to do this, right? We're going to get this business and test that. So let's go ahead and try it out with some old data that we had before. Let's go ahead and try this with some basic data. All right, here's some old data that we had. So what we need in this case, we've got two different ends. I've got people taking classes and not taking classes and their stress level, right? I have people who are taking classes, 1, 2, 3, 4, 5 of those. People who are not taking classes, I have 1, 2, 3, 4 of those. So the total n is going to be 9, but x bar sub 1 is 5, n sub 1 is 5, n sub 2 is 4. X bar sub 1 is 8.2, and x bar sub 2, is 5.75. So let's go ahead and get the pooled. We need to get the pooled variance so that we can then get the pooled standard deviation. So I need the variance for both of these things. And so let's just go ahead and show you. We'll just do the standard deviations as they normally are. So the standard deviation in this one, and I'm just going to square that, and then we're going to unsquare them in a second. So it's going to be the standard deviation of all of those. And then this is going to be the standard deviation of everything except for, okay. All right, those are the standard deviations. That means the variances are going to be the square of that. Good. Now, to get the pooled variance, we have to find n sub 1 minus 1 times the variance plus n sub 2 minus 1 times the second variance. And we divide that by the degrees of freedom. So for this one, we're going to take 1, 2, 3, 4, 5 of those. So 5 minus 1 is 4. So this is going to be 4 times the variance. And then this, we have 1, 2, 3, 4 of those. So n sub 2 minus 1 is going to be 3 times the variance. So this is going to be 3 times the variance right there. Okay, then I add those up. And this is what I get, 7.55. And then I take 7.55 divided by the degrees of freedom. Degrees of freedom is n sub 1 plus n sub 2 minus 2. So 5 plus 4 minus 2 is 7. So the pooled variance is going to be this divided by 7, 1.079. That's the pooled, then the pooled standard deviation is going to be the square root of that. .039. So this is the pooled standard deviation. Then what we need to do is we need to take x bar sub 1 minus x bar sub 2 divided by the pooled standard deviation. So it's going to be, this is going to be d, it's going to equal x bar sub 1 minus x bar sub 2 divided by the pooled standard deviation, and we get 2.359. Delta is going to be something more complicated, because remember, we have to do a little bit differently with what we've done before. We need to get this harmonic mean first. Then we can take the harmonic mean divided by 2 and get the delta. Yeah, so the harmonic mean divided by 2, get the square root of that times d. That'll give us the delta. So here we go. So delta first, before we even do the delta, we got to get the harmonic mean. And just to remind you what the harmonic mean looks like. It looks like this. It's n bar sub h. We need 2 times n sub 1, which is going to be 5, times n sub 2, which is going to be 4. So 5 times 4 is 20, times 2 is 40, divided by n sub 1 plus n sub 2, 5 plus 4, 9. So we need 40 divided by 9. So for this one, it's going to be 40 divided by 9. I just forgot what I was doing for a second. That's the harmonic mean. So now when we want to get delta, we need the square root of this divided by 2. So delta is going to be square root, sorry, it's going to be d times square root of this divided by 2. Okay? Effect size times the square root of the harmonic mean divided by 2. 3.51. 3.51 is our delta. When we look it up on the chart, we find 3.5 right there. That means that we have 0.94. Power equals 0.94. So 3.5 is right there. We look across, got to make sure I'm in the right place. 0.94. Yep, that's right. So power 0.94. That means that if there really is a difference in the stress level between people who do take classes or don't take classes, with all of my people, in this case I have 9 total people, I would have a 94% chance of rejecting the null hypothesis when the null is actually true. That's pretty good. So here's what I want you to do. I want you to try the same process with these data right here. Okay, so to do this, we need to find the pooled variance first. So let's go ahead and do that. The pooled variance is going to be n sub 1 minus 1. There are 1, 2, 3, 4, 5, 6 cat people, and 1, 2, 3, 4, 5, 6, 7 dog people. That's why I have n6 over here, n7 over here. So we need n sub 1 minus 1, which is 5, times the variance, which is 1.9. Okay? Then, so let's go ahead and get that first. So this is going to be 5 times the variance, 1.9. And then for the dog people, it's going to be 7 minus 1, which is 6 times the variance. So this is going to be equals 6 times the variance of the dog people, which is over here, 0.95. We get this. We're going to add those together. We get that. And we're going to divide this by the degrees of freedom, which is 6 plus 7, n sub 1 plus n sub 2 minus 2. So 13 minus 2, which is 11. So pooled variance is going to be this divided by 11. Then I need the pooled standard deviation, which is S sub P. And I get square root of the variance right there, 1.17. With that, then I can figure out D. So D is going to be mean sum 1, so x bar sub 1. I got to put some parentheses in here. X bar sub 1 minus x bar sub 2, right there, divided by standard deviation, the pooled standard deviation, 2.611. Okay, that's our D. Now we need to get delta. But to get delta, we need to get the harmonic mean. So let's get the harmonic mean. Harmonic mean has to be 2 times n sub 1 times n sub 2. So, and then we're going to divide that all by n sub 1 plus n sub 2. So let's go ahead and just kind of put it in here. We need 2 times n sub 1, which is 6, times n sub 2, which is 7. We're going to divide that by n sub 1 plus n sub 2, which is 6 plus 7. 6.461, whatever, right? Now we take this divided by 2 and take the square root of that times D to find delta. So delta is the effect size times, times the square root of the harmonic mean divided by 2. 4.69. 4.69. That's a big delta. When we look on the chart then, we see that 4.69, even if we went down right here, we're still at 0.99. So this is 0.99, this is above 0.99. So this is going to be is 0.99. In fact, it's greater than 0.99. If there's a difference between how much tea cat drinkers and dog drinkers drink, then this study has a 99% chance of finding it, of rejecting the null hypothesis when the null hypothesis is false. Okay, thanks everybody.